Question 14. Express 3 over 2x minus 1 x plus 1 in partial fractions. Now we have a proper fraction here where the degree of the numerator is less than the degree of the denominator, and our denominator is already split into two linear factors. So as partial fractions, we can write this as equivalent to sum a over 2x minus 1 plus b over x plus 1. Multiplying both sides by this denominator here, the 2x minus 1 x plus 1, leaves us with 3 on the left hand side being equivalent to, now a multiplied by 2x minus 1 x plus 1, the 2x minus 1s will cancel to leave me with a lots of x plus 1, and similarly when multiplying the b by 2x minus 1 x plus 1, the x plus 1 will cancel, leaving with b lots of 2x minus 1. Now we can use substitutions to find the value of a and b, and if we substitute values which will eliminate a or b, this makes it simpler to solve. So let's let x equal negative 1 first of all to cancel the a value. Therefore 3 on the left hand side is equal to, the a term disappears, and I'm left with b lots of minus 2 minus 1, which is minus 3b is equal to 3. Therefore b must equal minus 1. If we wish to eliminate the b, then we'll need to let x equal a half. So substituting x is equal to a half gives us again 3 on the left hand side is equivalent to a lots of a half plus 1. A half plus 1 is 3 over 2. So we have 3 is equal to 3 over 2a. Therefore a must be equal to 2. And so as partial fractions, 3 over 2x minus 1 x plus 1 can be written as 2 over 2x minus 1 minus 1 over x plus 1. When chemical A and chemical B are mixed, oxygen is produced. A scientist mixed these two chemicals and measured the total volume of oxygen produced over a period of time. The total volume of oxygen produced, Vm cubed, T hours after the chemicals were mixed, is modelled by the differential equation dV by dt is equal to 3v over 2t minus 1 t plus 1 for v greater than or equal to 0 and t greater than or equal to k, where k is a constant. Given that exactly 2 hours after the chemicals were mixed, a total volume of 3 meter cubed of oxygen had been produced, part B, solve the differential equation to show that v is equal to 3 lots of 2t minus 1 divided by t plus 1. Okay, so we are starting with our equation that's given to us. We've got that dV by dt is equal to 3v over 2t minus 1 t plus 1. Now, when we're solving this type of differential equation, we would like to have the dv on one side with the v's and the dt on the other with the t's. Process we call separation of variables. Rearranging this, bringing the v's to the left hand side and taking our dt to the right, we have that the integral of dv over v is equal to the integral of 3 over 2t minus 1 t plus 1 dt. Looking at the right hand side, we have something that looks very similar to what we were given in part A. Now this is a huge hint that this can be rearranged into a form that is easier for us to integrate. And so in fact this is equivalent to still dv over v on the left hand side is equal to the integral of our partial fractions, which was 2 over 2t minus 1 minus 1 over t plus 1 integrated with respect to t. Now having made our substitution, we're in the very fortunate position where our numerators in each of these two fractions are the derivative of the denominators. And as such, we can use our natural logs to integrate each of these. So 1 over v becomes ln v. This, since the numerator is the derivative of the denominator, becomes ln lots of 2t minus 1. Similarly, we are subtracting here ln of t plus 1, again, as the numerator is the derivative of the denominator. and then not forgetting our plus c for integration. We then can use our boundary conditions set in the question. We know after 2 hours, the chemicals mixed produce a volume of 3 meter cubed oxygen. And so when T is equal to 2, V is equal to 3, this gives us that ln V is equal to ln of 2 times 2 minus 1 is 3, minus 2 plus 1 is again 3. So these ln 3's will cancel, and so C must be equal to ln 3. Putting that into our equation gives us ln V is equal to ln 2t minus 1 minus ln t plus 1 plus ln 3. So starting at this point, we're going to use our log rules here. So let's take one at a time. If I look at these two first of all, ln of 2t minus 1 minus ln t plus 1 is the same as ln 2t minus 1 divided by t plus 1. When we add two logs together, we multiply. So we have that this is the same as ln 3 lots of 2t minus 1 over t plus 1. We can now take exponentials of both sides and see that V is equal to 3 lots of 2t minus 1 over t plus 1, which is what we wanted to show. The scientists noticed that there's a time delay between the chemicals being mixed and the oxygen being produced. There was also a limit to the total volume of oxygen produced. Deduced from the model, the time delay giving your answer in minutes, and then II, the limit, giving your answer in meter cubed. So what do we mean by time delay? So there's a time delay between the chemicals being mixed and the oxygen being produced. So this volume of oxygen being produced is 0 up to the point when the oxygen starts to be produced. So if we let V equal 0, we have that 0 is equal to 3 lots of 2t minus 1 over t plus 1. Multiplying up by the t plus 1, dividing by 3, we can see that our 2t minus 1 must equal 0. Adding 1 and then dividing by 2 gives us that t must equal a half. And because t is in hours, this is 30 minutes, giving our answer in minutes. So what does this mean? It means that when these chemicals are mixed, it is 30 minutes until any oxygen is produced. What is the limit of that amount of oxygen, giving our answer in meter cubed? Now the limit, if we let this experiment run for a long period of time, so we're thinking about when t tends to infinity. Now looking at our V is equal to 3 lots of 2t minus 1 over t plus 1, if we expand the numerator here to give us 6t minus 3t plus 1, when we are considering the limits as t tends to infinity, we can look at the ratio of these leading coefficients, since the degree of the polynomial in terms of t is the same. And so we can see that V is tending to 6 as t tends to infinity. Another way of thinking about this, if we have 6 times an extremely large number, taking away 3 makes little difference. Again, the same large number adding 1 makes very little difference. So 6t divided by t. And so as t tends to infinity, V tends to 6 meter cubed.